Welcome to session 2.13 of your chapter Optics. In this session, we'll be discussing what is magnification of a lens. And as usual, before doing this, we'll be recollecting what we did in the last session. In our last session, we discussed what is sign convention under two parts. Two parts also explain the same thing, but the difference is the second part explains these six rules by line. And very simple is that you need to take the measurements which are taken in the direction of incident ray as positive and opposite to that as negative, and from anywhere you need to start measuring at the distance of image or object from the optical center of the lens. And then uh, the height, well, the height of an object is always taken as positive, and for a better clearance we can say that a line which is pointing upwards from the principal axis of a lens is taken as positive, and the opposite, that is the line which is pointing downwards from the principal axis, is taken as negative, and this is called as the sign convention for lens. Then coming back to the topic, magnification of a lens. So what is magnification? As usual, you might have thought that magnifying means making objects bigger, but here the context is different. Magnification means how smaller or how bigger the image is seen when you compare it with an object, and that's called as magnification. Since this topic is related with lens, they gave the topic as magnification of a lens. Going with the paragraph, like a spherical mirrors. You might have shown and read about spherical mirrors in your class 9th, and if you need a clear cut idea about this, just take your book and learn it. I can't do anything in that. Comma, we have magnification for spherical lenses. So same like spherical mirrors, we have magnification for spherical lenses also. Spherical lenses produce magnification, and it is defined as the ratio of the height of the image to the height of an object. They told that magnification is equal to ratio, that means this one, division, for height of the image divided by height of the object. This is what they told in this line and that previous line. Magnification is equal to height of the image divided by height of the object. Magnification is denoted by the letter m, small m. If the height of the object is h and the height of the image is h dash, the magnification produced by lens is h dash by h. And here you need to see one thing. Also, it is related to the distance of the object u and the distance of the image as follows v. Okay, we know before that the distance of the image from the optical center is denoted by v, and distance of the object from the mirror from the lens is denoted by u. uh, since we have two formulae for a mirror also, na, mirror's magnification is equal to hi by ho, which is also equal to, I think, minus v by u. That's for mirror, and for lens there will be no minus, it will be plus v by u. That's all. Magnification is equal to distance of the image divided by distance of the object, which is equal to v by u, which is also equal to h dash by h, which is equal to height of the image by height of the object. And here you need to use sign convention or you'll be getting wrong answers. Before going to the last paragraph, I need to explain you one thing, that take the case of a convex lens. Okay, you know a convex lens, right? Convex lens, and this is C, center of curvature, and this is F. As for us, it is considered as the focus, and here the object is placed. By using sign convention, we can say that the distance may be plus 5 centimeter. Okay, plus 5 centimeter. Why plus? Because the arrow, I mean the direction is upwards, and we are going to measure it in this direction. The principal axis is below that, so we are taking it as positive 5 centimeter. And after that, this image will be forming that object will be forming its real image behind center of curvature, so somewhere here, and it will be a bit bigger, right? You can verify it in the above 6 sub cases which is taught for refraction of convex lenses. Okay, and the image will be formed here, and it is a real image, so it is inverted also, and it is pointing downwards, so we gonna take the height of this image as minus 8 centimeter. Why minus? Because the image is inverted and it is pointing downwards from the principal axis, and due to sign convention we are going to take it as minus 8 centimeter. And later, to calculate magnification, what we need to use is height of the image is minus 8 centimeter divided by height of the object is 5, and after solving it we'll be getting minus 1 point balance 3 it's 6 1.6 is the magnification. And what does this minus indicates is the image formed by the object is real image. This minus sign indicates the image formed is real, and this 1.6 indicates that the image is bigger than the object with a multiple of 1.6. Wait a minute. Okay, the image is greater than the object because 1.6 is always greater than 1, right? That 1.6, that value alone you need to see, to understand this last paragraph. If the magnification is greater than 1, we saw, right? What we saw here is minus 1.6 is the magnification, right? If the magnification is greater than 1, well, you can ask that minus 1 is always lesser than 1, right? This is according to mathematics. Okay, and here you won't be considering the minus symbol because this minus only indicates real and inverted image, and what you need to see is this magnitude. Only you need to take the magnitude to understand this last paragraph. If the magnification is greater than 1, here it is greater than 1, right? 1.6 is always greater than 1, then we get an enlarged image. Well, we know already, right? When an object is kept in between center of curvature and focus of a lens, of a convex lens, it forms a real image which is bigger than the object behind the center of curvature of the opposite side, right? This is what we learnt in that before sessions and all, and that's what they are saying here. We get an enlarged image, and here the minus sign indicates real and inverted image. On the other hand, if the magnification is less than 1, then we get a diminished image. See, for this I can explain you with a new case. Consider this as the principal axis, and this is convex lens, right? Convex lens, and this is focus, and then this is center of curvature, and we are going to take the object here behind center of curvature. So as far as our ray diagrams and ray rules are considered, the image will be formed in between focus and center of curvature, and the size of the image is smaller than the size of the object, and for this we'll be having some minus 5 centimeter as height of the image, and for this it will be 8 centimeter. So for calculating magnification, what we'll be taking is minus 5 by 8. We can simply say that the answer will be minus 6 minus 0.6 something, right? And this minus sign indicates the image is real, and we need to see only this magnitude. 0.6 is always lesser than 1, and we hence proved that if the magnification is less than 1, we will be getting a diminished image. Diminished image means smaller sized image. Well, That's all for today. And magnification of a lens topic is over. Smaller to denote magnification, the formula is height of image by height of the object. We need to use sign convention for this for a clear cut understanding of the properties. Fine. If you have any doubts, just comment it in the comment section. And the upcoming topic will be lens makers formula. We'll be learning it deeper. You'll understand it better. It's very important. And then that's for today. Thank you. Bye bye.